Thank you. Let me show you a video first.
Γεια σου.
Γεια. Με λένε οι τύποι ότι θα δούμε μαζί την έκθεση της αγοράς. Ξεκινάμε.
Ναι.
Τέλεια. Θα δούμε πολλά καινούργια πράγματα. Ξενάγηση ενήλικου ή παιδιού.
Ενήλικου, παρακαλώ.
Είπατε ότι θέλετε ξενάγηση για ενήλικο.
Ναι.
Τέλεια. Ξεκινάμε από την Δύση.
Όχι, από το κέντρο.
Εντάξει. Το κέντρο έχει πολλά ενδιαφέροντα κτίρια. Τώρα ας δούμε τον νομό του Αγορέδιος. Ελάτε να πάμε από εδώ.
Πάμε.
Ο βωμός του Αγορέδιος βρίσκεται στο κέντρο της αγοράς. Βρισκόταν αρχικά σε κάποια διάμορφη θέση, πιθανώς πινκνίκα. Υπάρχουν ερωτήσεις, απορίες?
Πότε χτίστηκε ο βωμός του Αγοραίου Διός?
Ο βωμός του Αγοραίου Διός χτίστηκε τον 4ο αιώνα π.Χ. Υπάρχουν ερωτήσεις, απορίες?
Όχι.
Και τώρα ας δούμε το οδείο του Αγρίπα. Ελάτε να πάμε από εδώ.
Πάμε.
Υπάρχουν ερωτήσεις, απορίες?
Τι είναι ο βωμός?
Ένας βωμός είναι μια αρχιτεκτονική κατασκευή. Ο βωμός ήταν οποιοδήποτε κτίσμα, συχνά κοντά ή μπροστά σε ναό, στο οποίο γίνονταν θυσίες και προσφορές για θρησκευτικούς λόγους. Οι βωμοί ήταν είτε χτιστοί από πέτρα ή μάρμαρο, είτε αποτελούσαν σωρό χώματος ή στάχτης από προηγούμενες θυσίες. Ο βωμός είχε κατασκευαστεί. Υπάρχουν ερωτήσεις, απορίες? Τέλεια. Σας ακούω.
Τι είναι η Αθήνα?
Η Αθήνα είναι μια πόλη. Υπάρχουν ερωτήσεις.
Από τι είχε κατασκευαστεί ο βωμός?
Shrine. This way. The triangular shrine is located in the southwestern part of the Agora. It was built in the 7th century BC. It was in use during the Archaic, Classical, Hellenistic and Roman periods. It was possibly used as a place to venerate the dead of the nearby cemetery. Is there anything you want to ask?
When was the triangular shrine built?
That's a very interesting question. The triangular shrine was built in the 7th century BC. Is there anything you want to ask?
What can you tell me about the Hellenistic period?
Ah, that's a good question. The Hellenistic period lasted from 323 BC to 146 BC when Corinth was destroyed by the Romans, or, according to others, up to the victory of Octavian at Actium in 31 BC, it was a transitional period from the Greek city-states to the vast kingdoms, which eventually led to the emergence and subsequent dominance of the Roman Empire. Do you have any questions?
No.
Let's visit the Impium. Follow me, please.
Who was Emperor Hadrian?
Excellent question. I think I can answer that. Hadrian was Emperor of Rome from 117 to 138 AD, as well as a Stoic and Epicurean philosopher. He was a member of the Antonine dynasty. He was a great admirer of Greek culture, and his building program for Athens included the Olympi, a temple and a new library. Is there anything you want to ask?
Right. Thank you.
Γεια σου.
Γεια. Με λένε η Τίκο και θα δούμε μαζί την έκθεση της αγοράς. Ξεκινάμε.
Ναι.
Right, so the robotic guide that I showed you was developed during the Indigo project, which was a project funded by the European Union. Now, one of the things that are interesting about this robot is that the descriptions of the monuments of the ancient Agora of Athens that the robot produces, as well as the answers of the robot to the questions of the users, are not pre-recorded. The robot produces on the fly a text describing each monument from an owl ontology. If you don't know about computer science ontologies, think of an owl ontology as a kind of a database. So in this case, the author is the robot, right? So the robot produces a text describing the monument, and then this text is passed on to a text-to-speech synthesizer. This is a tool that can be used to edit the ontology that the texts are generated from. So, for example, it shows that, oh, can I point to the screen right here? I think I know how to do this. No? Yes. So, for example, it shows here that exhibit 17, if you can read this part, which is an exhibit, is in the class of imperial portraits, and that an imperial portrait is a statue, and that a statue is kind of an exhibit, right? And then on the right side, these fields provide information about this particular exhibit. So in this case, one of the fields says that, the last one, that this statue portrays Octavian Augustus, if I pronounce this correctly, and Octavian is an entity in the class of Roman emperors, as you can see on the left. Another field says that this exhibit was created during the Roman period, and the Roman period, again, is an entity in the ontology. You'll find it here under the type, the class, historical period. And here you can see the corresponding text that the system produces from the ontology, here in Greek, and then the same content in English. Now, some of the values of the fields on the right side may actually be short canned texts. So, for example, this last sentence here, the one that says that this is one of the best examples of a propaganda statue, this sentence is a canned sentence stored directly as the value of a field. But for all the other fields, for example, a field that says what was the period the exhibit was created in. For all the other fields which in fact express logical facts, the system knows how to automatically create a sentence in the appropriate language, for example in English or Greek, and also how to order the sentences to produce a coherent text, and also how to aggregate sentences to form longer ones, or how to produce appropriate pronouns and so on. Now, of course, you may wonder if a robot would be actually useful in a real museum. This kind of technology may be more useful in virtual museums, where usually there is no one around to guide you. A few years ago, we used similar technology to develop a robotic guide for a virtual museum in Second Life. Second Life is a virtual museum where each user controls an avatar. Here, this is my avatar, my body, and whenever I touch an exhibit, a coin, for example, in this case, there's a little robot here that produces a text describing this exhibit, and the text is shown as subtitles. An even more convincing application might be to use mobile phones. A few years ago, two of my former students won several national and international prizes with this mobile application. So what happens here is that in this particular example, the user is in the ancient Agora of Athens. So the user first logs in, you provide a username here, then you select the language that you prefer, for example, Greek, then how short or long the generated texts have to be. Then you also select a user type. There's also a choice about whether or not the generated text should contain comparisons to previously seen monuments in this case. And then the system, the mobile phone in this case, shows a list of nearby monuments. So when you select a monument, the system produces, again on the fly from an ontology, a text describing the monument. And of course, a text-to-speech synthesizer can also be used. And the user can also ask follow-up questions. For example, if the text mentions Attalus, then the user may ask for more information about Attalus. And then again, the system would generate a text on the fly from the ontology for Attalus. And I should also say that the texts vary a lot. So they can be, for example, in English or Greek. They can be shorter or longer. We change the kinds of expressions that we use, for example, the vocabulary or the syntactic complexity, depending on the user type. So we produce simpler texts for children. For example, you do not want to include references when talking to children, but you want to include perhaps references when talking to experts, and so on. And this is now freely available as an app for iPhones that can be used on the Acropolis. So if you visit the Acropolis, you can actually use it. And let me now switch to a completely different context. In another European project I'm involved in called Bioask, we're trying to help biomedical experts who search for information in the literature. In 2011, there were approximately 20,000 new biomedical articles published per week. Pubmed is a repository that holds information about all the published biomedical articles. And things are actually even worse, because apart from numerous articles that are being published, there are also numerous linked data biomedical collections. If you don't know about linked data, think of them as online databases, which you would also have to search. So during Bioask, we asked biomedical experts to formulate English questions that would reflect their real needs. When I say real needs, I mean they should reflect information that the experts need for their own research. And we have several different kinds of questions. This is an example of a so-called factoid question. Strictly speaking, the answer should be the name shown here as exact answer. But of course, in real life, an expert would like a paragraph probably shown here as the ideal answer. So the idea is that the ideal answer is actually a summary summarizing all the relevant information from the literature and linked data. And it may, for example, contain information coming from several different articles. Here's another example. This is a so-called list question. So in this case, strictly speaking, the answer should be the list of species names shown here as the exact answer. But again, ideally, the expert would also like to see a summary of the most relevant information from the literature. Now, in practice, a biomedical expert would go to a specialized search engine, like the one provided by Pubmed, and here's a screenshot. But these engines do not directly support English questions, so the expert would have to formulate something like a Boolean query. And of course, the result would be a list of possibly relevant articles. And then the expert would, of course, have to read the articles to find the answers inside the articles. So Bioasc tries to push towards systems that will be more helpful than existing search engines. So what are we doing in Bioasc exactly? Bioasc is a competition for systems which is funded by the European Union. And it comprises two tasks. The first task is about hierarchical text classification. The organizers of the competition distribute new Pubmed articles to the participating systems as the articles get published. And before the Pubmed curators have assigned mesh terms to the articles. Mesh terms are tags that describe the content of the articles. And Pubmed has many human curators that try to tag each new article with the corresponding, the correct mesh terms. So before the human curators have had time to assign the correct mesh terms to new articles, we give the new articles to the participating systems, and the systems respond by providing the mesh terms that they think are appropriate. And then when the correct mesh terms from the human curators become available, we evaluate the results of the systems against the correct mesh terms of the human curators. The second task is about information retrieval, question answering, and multi-document summarization. So what happens here is that the organizers distribute to the participating systems English biomedical questions. And the participating systems respond by providing for each question relevant Pubmed articles, relevant snippets, pieces of the relevant articles, relevant concepts from designated ontologies, relevant linked data triples, exact answers, for example, names of genes or species, and paragraph-sized summaries answering the questions. And the responses of the systems are evaluated both automatically and manually by biomedical experts. Now, the reason I have been telling you all this is that I'm wondering, would it be useful to organize a similar challenge for digital humanities? And before answering the previous question, we should probably think about this second question, which is, how do researchers of digital humanities search? Do they use ways that are similar to the ways that biomedical experts use when they search in their huge online repositories? And of course, where do digital humanities experts search? Do they actually use online repositories? And if yes, which ones? So would it be useful to try to collect hundreds of questions written by digital humanities experts so that the questions would reflect the real needs of the digital humanities experts? And then we, of course, we would have also gold answers, meaning for each question, relevant articles, relevant snippets from the articles, exact and ideal answers. And we could try to use these questions and the gold answers to set up a challenge similar to Bioasc. So a challenge for systems that would try to come up with these answers, but this time it would be for digital humanities, not for biomedical research. And of course, digital humanities is a very broad term, so which subfields of digital humanities should we target? And of course, where could one find funding? So if you are interested in this kind of work, please contact me, because I and other colleagues are trying to come up with a proposal for funding for this kind of work. And also, if you know any of the answers to these questions shown here, again, please contact me, because I don't actually know the answers. Thank you very much.